So there are a few variations that we need to look at now that we understand the basic idea for evaluating these limits at infinity. The first one is based on what you saw in that Desmos activity, the idea that the square root of x squared is not x, but rather is the absolute value of x. With this in mind, I want to go do the limits as x approaches infinity of 3x minus 2 over the square root of 4x squared plus 1. Limit as x approaches infinity of 3x minus 2 over the square root of 4x squared plus 1. Well, looking at the limit of the ratio of the leading terms, I'm going to get the limit as x approaches infinity of 3x over the square root of 4x squared. And this gives me the limit as x approaches infinity of 3x over, well, square root of 4 is 2, and square root of x squared, don't say that it's x. Square root of x squared is the absolute value of x. We are not allowed to just cancel the x and the absolute value of x. What I need to think about is kind of the whole write this as a piecewise function thing, but I can make it simpler than that. If you're plugging in a huge positive number over here, is the stuff inside the bars positive, or is it negative if you're going to plug in a huge positive number? Well, if you plug in a huge positive number, the stuff in the bars is positive. To take the absolute value of a positive, we can just drop the bars. So because I'm plugging in something positive, I'm going to get the limit as x approaches infinity of 3x over 2x. Now, we can make those x's cancel. Limit as x approaches infinity of 3 over 2. And we're going to end with 3 halves for that limit. Let me show you 2 more of these. Let's take a look at the limit as x approaches negative infinity of, let's do the same thing. 3x minus 2 over the square root of 4x squared plus 1, which will equal the limit as x approaches negative infinity of 3x over the square root of 4x squared. That's the limit as x approaches negative infinity of 3x over 2 times the absolute value of x. Same thing it was before. Nothing's different in the work yet. Now, if you go to plug in a negative huge number to the stuff inside the bars, well, that's going to make the stuff inside the bars negative. How do you take the absolute value when the stuff inside the bars is negative? Well, to take the absolute value of a negative number, we have to change its sign. So we're going to get the limit as x approaches negative infinity of 3x over, change the sign of this thing, 2 times negative x. Why don't I just write it as negative 2x? Well, at this point, I can cancel the x's. And then I no longer have any x's inside that limit, so my limit is just that constant that I was getting inside there, negative 3 halves. You try this next one on your own. Pause it if you're on YouTube. Edpuzzle will stop for you and ask you for the answer. See what you can do with this. Okay, well, if you're plugging in a negative number to the bars, to take the absolute value of a negative, we have to change its sign. So I'm going to make this the limit as x approaches negative infinity of negative 3x over negative, change the sign, of x. Remember, this does not mean the bottom is negative. It means x was a negative, and this is changing its sign, making it positive. I can simplify this down to a 3 inside that limit, and I'm going to get 3 for my answer. Hopefully that's what you got. Then we also need to look at some trig stuff. First one. The limit as x approaches infinity of the sine of x. The limit as x approaches infinity of the sine of x. Any idea what this might be? Well, if we look at the graph of the sine of x, just focus on the positive direction here. So it goes up, and then down, and then up, and then down. As we go far to the right, it keeps bouncing between -1 and +1, including all the values in the middle. This limit does not exist. Not for any of the reasons we've seen before, not because there's a hole, an asymptote, or any of those things, but because we just sort of keep bouncing through all those different x values, through all those different y values, and we're not leveling out or anything like that. Sine x just alternates between positive and -1 and everything in the middle. However, what if we look at the limit as x approaches infinity of the sine x over x? First of all, this is not going to equal 1. That was what we got when that was our special trig limit when we were doing the limit as x approaches 0 of sine x over x. This is totally different. This is the limit as x approaches infinity of sine x over x. So not going to work that way. I don't know what's going on with the top, but I know that it's going to go between -1 and 1. The top is some number between -1 and +1. I'm actually going to use something we haven't talked about in a little bit. I'm going to use that squeeze theorem here. Watch how this works. By the squeeze theorem, the limit as x approaches infinity of the sine of x over x. I know that the absolute lowest that this numerator can be is -1. So I'm going to say that the limit as x approaches infinity of -1 over x is less than or equal to the limit as x approaches infinity of the sine of x over x, because -1 has to be less than or equal to all other values of sine x. And I think that numerator, that sine x, can't be any bigger than 1. So I can say that thing is less than or equal to the limit as x approaches infinity of 1 over x. You know what? See if you can finish this off. See what you can do. This limit over here, -1 over a huge number, that's 0. This limit over here, 1 over a huge number, that's 0. Therefore, the thing in the middle has got to be 0. One last thing I want to do in this video, I'm going to quickly go through the flowchart, where we are on that flowchart. We're finally looking at that branch that's on the side. Are we evaluating a limit as x approaches a number, or as x approaches plus or minus infinity? We're approaching positive or negative infinity, which means we're going to consider the infinite limit of the leading term of the numerator over the leading term of the denominator. We'll simplify and we'll evaluate. I think I need to change this language a little bit. Simplify and evaluate, plugging in a huge number and seeing what happens. What is really, really, really important is that these methods we've been looking at in section 3.5, you only use if we're doing the limit as x approaches infinity or negative infinity. If we're doing x approaches 2, you're not doing any of this stuff. You're following the number branch on the flowchart and using the other methods that we've looked at in this unit.